that. Here, 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 here. Hi, good morning. I think I am good. Right about now, I'm happy that we started with 30 kids in this classroom, because if we only started with like 20, I don't want to have like 5 of you probably, I guess, so I'm okay with that. Don't look awake. You okay? You look sleepy. You okay? I know, you can't tell that I'm looking at you. Yes, I'm looking at you.
Oh, yeah, I'm fine.
Okay. Good?
Yeah.
Okay. How are you? All right. So y'all heard my little deal, right? My little spiel. I hope you read whatever. So today we'll cover any questions you have over 7.4. I'm sorry, 7.3.
Oh.
7.3. We'll cover 7.4. 7.4 and 7.5 are almost exactly the same. They're just solving equations. So pretty much I don't have to do a whole lot on 7.5 other than 7.5, just a little bit more difficulty. So we'll cover 7.4 today. Like I said, it's just solving equations. And then Thursday, we'll work on 7.5, 7.4, whatever we need with. Friday is a virtual day. I'll see everybody online if you want to. Again, I'm not going to require you to get online, but if you want to, we can, and that's a review day. And then Tuesday, we're going to take a test. If we're still 50-50, half you guys will take the test on Tuesday, and then the other class will take it on Thursday, because I'm going to give it to you on paper. Is the plan, because I just don't think I can do this on GoFormative. Can't see how you can prove an identity on GoFormative other than, I don't know how you can prove it. Yeah, I mean, I don't know. And I sure don't want you to type all that stuff out. So I think we're just going to do it on paper. Best I can tell as of right now. Now, if there happen to be several of you home for some reason or another, I'll have to readjust. But I think we're going to try to go on paper. You had something?
You answered it for me.
Okay. Talk to me.
On the test, will we?
Yes, you will be able to use that, the sheet that you have the identities on. I don't want to say formulas, but identities. You will be able to use that. No calculator, but I can't imagine why you would even need a calculator for it, because we haven't used one much at all. You can cheat, I guess, with a calculator. That's why. If I wanted you to find the exact value of, cosine of 35, and so you had to go through that whole thing and find the exact value. Well, if it's multiple choice, you can just punch that up and punch those up and see which ones match. Anyway, that's our plan as of now. As y'all know, throughout this year, those plans can change in an instant, but that's kind of what we have laid out. If it's not 50-50, we're still going the test Tuesday. Either way, and it will be, I don't think you make it, we're still going 50-50. I think we're still going 50-50 at least for 2 more. I kind of think we're going to do it till spring break, but they haven't told us anything. Truth be told, until the numbers start going down for the state, and they actually went down for the first time in a while, but they're still freaking high. Okay, I got my shot. No, first one. Still sore. That was Friday.
They already gave it to you guys?
Yeah, I got my first one Friday. Only us old ones got it. They only had 500 for the entire district.
When's the second one coming in?
It's the 12th, I think I have to do it. It's the 12th. And they say that one even hurts a little bit more, so I don't know. I felt okay though, so that's good. Whatever. Anything to try to get back to normal, I'll do it. All right. don't know if anybody's there or not, but if you are, hello. I don't know who's going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think that's about right. I lied. I said it's about right. All right, ladies and gentlemen, it's your turn.
Can you do 39?
I can hope I can. Y'all do know, okay, here's my, I'm going into these blind meals. So if I get to going, you only have to stop me and fix it. 39?
Yes, please.
39. Cosecant of 3. Find, find sine of x over 2, cosine of x over 2. Okay. Woo, that's a bad question. Holy cow, that's like 3 questions in one. Any particular one you want me to do?
I just didn't know where to start.
Okay. Where's my pen? Nope, not here. That's the question. Here. Here. All right. Let me take a picture of this thing. I need this top part. Well, no, I don't, because it's just a half angles. 39. Friday, I'll tell you a little bit more. We pretty much got the test laid out. Friday, I'll for sure tell you what you need to make sure you hit. All right. Cosine, and they want me to find sine, cosine, tangent of the half angles. So I'll just do, it doesn't matter. I'll do sine x over 2. That's the one I want to find, okay? They're telling me that cosecant of x equals 3, which is a little weird. And they're telling me that x is between 90 and 180 degrees. So all they're telling me is that x happens to be in quadrant 2, okay? And I got to draw the triangle. Anytime you see something like this, you're going to draw a triangle. I don't know what the angle is. I don't know what the angle is. I know the angle is somewhere in the second quadrant. I don't have any idea what it is, but I know the cosecant of that angle is 3. And so I'll just draw a triangle. And cosecant is hypotenuse over secant is sine. So it'll be hypotenuse over adjacent. Opposite. Sine is opposite. So 3 over 1. It's a little different because we haven't seen like a whole integer like that. 3 over 1. And if I do 3 squared, which is 9, and take away 1, which is 8, and that's the square root of 8, which is 2 root 2. And that'll be negative because that's in quadrant 2. And if you can do that part of it, you're pretty good ways on the way. Because again, this is the angle. Oop, it's not. It's just x. That's the angle. So I want the sine of that half angle, and now I gotta know the sine, half angle sines or half angles. Is that the square root, big square root? Oh, what's that? What's the half angle formula? Is that a big square root formula? I think it is.
Yeah, it is. The plus or minus.
Yeah, it's plus or minus, and it's
1 minus cosine x over 2.
and that's why we're giving you all those, right? I don't even know. Everybody okay with that? That's what the sine of theta over 2 is. So let's first decide if it's positive or negative. Sine in quadrant 2 is positive. So that's where we get the plus and minus from. You just have to look at what the angle is. I don't know if I want the sine of that angle in quadrant 2 or quadrant 1, but either way it's positive. I need to verify that part of it. And so now I'm just going to do 1 minus the cosine. Actually, I don't even need to write that. Cosine of that angle. and cosine is adjacent over the hypotenuse. And adjacent is negative 2 root 2 over 3. And this whole thing is over 2. And then this whole thing is square rooted. And now we're pretty much done. We just got to simplify it a little bit. We'll make this 3 over 3. 3 minus root 2 over 3, which is 3 plus root 2. And all this is over 3, and all this is over 2. When I flip and multiply it, that makes it all over 6. Because that's 1. The 1 goes up here, the 2 goes down here. So that's going to make it look a little bit cleaner. 3 plus 2 root 2 all over 6. And that whole thing is rooted. Leave it like that. It's hard to get rid of a radical inside of a radical. You can, you just have to make it all to the 4th. And does that help you?
Yeah.
Once we draw it, it says, oh yeah, so it's a little click or something. What about the cosine answer of that one? Is the cosine answer of that one negative or positive? Y'all have that pulled up by chance? That's what I'm thinking. I think it should be negative, but if it's positive, is it negative?
Well, I don't know.
Oh,
I'm
well, somebody.
assuming it should be
If it's the
negative.
larger angle, then it would be positive.
Yeah, I know. I don't know if I'm supposed to look at the angle or half of the angle. If it's half the angle, it's going to put it in quadrant 1.
I think it's half the angle. 'Cause I
That's
remember
it.
looking at it.
So you think it's positive?
I think-
Let me look.
Yeah, it is.
It is positive?
Wait. Go look at it.
Okay, let's look at it. Here, I need to go open. No, I don't want to do that. Well, I could do that, I guess. Oh, that was recent. That was recent. Did I not have recent? Reopen PDFs from last session.
Do you all recent files?
Is there recent? Oh, that down here. Answers. Oh, that's the way I want to do it. Oh, I don't want all those answers though. I want 7.3 answers. There we go. That's what I was trying to get to. 7.3. Well. Heck with it. No, I know. Here, let's just do it. Sorry. Can't outfox a foxer. I told you all that. Google Drive, my drive, shared drives, pre-cal, chapter 7, 7.3 answers. Here we go. What number is that? 39.
Yes. 2,000.
The sine is that. Cosine, positive. Okay. So cosine is positive. So, okay, that's trick. Okay.
Why would that be positive?
Yeah, we're going. I'm getting ready to explain. I thought it was a little low on that. So decide on if this is positive or negative. Okay, we have to see where theta is, but we can't see where theta. We have to see where x is. But x is here and it's x over 2. So if it's x over 2 and we're in quadrant 2, then that really cuts this x in half, which puts it in quadrant 1. Because I want the cosine of x over 2. I don't want the cosine of x. Cosine of x is negative. Cosine of x is negative. The cosine of x over 2 actually puts x over 2 in quadrant 1, which makes it positive. Does that kind of follow that? So each one of those should have been positive because it's sine of x over 2. I said sine happens to be in quadrant 2. It's not. It's actually in 1. X over 2 is in quadrant 1, so that's what makes it positive. cosine, it puts it in quadrant 1 because of the x over 2. And if you can't figure out why it's in quadrant 2, x is what, greater than 90 and less than 180. Well, if you divide everything by 2, that puts this at what, 45? And that puts that at 90. If you divide everything, so x over 2, over 2, over 2. So that's why it puts it in quadrant 1. The x over 2. Fair enough? So that's how we decide if it's positive or negative. I hope that's not a big mind scout for you. I don't want that to be a big deal. If you can get this part of it, you've got 70, 80, 75% of the problem knocked out. Because then it's just plugging it into your formula or your identity. Just knowing, you have to know if it's positive or negative. Now the value is still negative because it was cosine of x, right? So that puts x in quadrant 2. But when it's x over 2, that actually put it in quadrant 1. A little confusing. And I could see how that definitely could be. Hopefully that cleared that up. Okay, we're good on that one?
Yes, thank you.
Talk to me.
Can you help me? 49.
4-9. Oop, where'd it go? Over here. I don't want this one. 49. 49. Barely there. I'll write the given expression as an algebraic expression in x. We didn't put this on the test. I didn't see it. All right. Sine inverse, that's an angle. That's an angle, that's an angle, that's an angle. It's almost just like the last question. We had what, cosecant of x equals 3. Well, this one I don't have cosecant of x, I actually have sine, but I have sine of x equals 1/4, which is the same thing as sine inverse of 1/4. Those two are the same thing. This is the same thing as cosecant inverse of 3. Well, they can rewrite those any way. Okay with that part of it? All right. So I need secant of that angle. Double that angle. All right. Pencil. Triangle. 1/4. Opposite over hypotenuse. 4 is 16 minus 1 is 15. Square root of 15. Sine inverse always puts, if it's positive, it puts it in quadrant 1. If it's negative, it puts it in quadrant 4. Remember that from last year. Okay, sine inverse. If it's positive, it's in quadrant 1. That's why they didn't have to tell me what quadrant it's in. When they do it the top way over there, they have to tell me what quadrant it's in. So I need secant of the double angle of sine, and the double angle of sine is 2 sine x cosine x. Which is secant of 2 sine x is 1/4. Cosine of x is square root of 15. Which gives me secant of 2 root 15 over 16. I hope I'm going about this right. Secant root 15 over 8. I don't know what the answer is. Is that the answer or? Okay, we'll look at what the answer is. Or the instructions. Rewrite it as
It was find the simple version, or you looked at the one above it.
Oh, okay.
It said like algebraic.
Yeah, I thought I saw something about algebraic something.
That was in the question above it.
Oh, that's a question above it.
Yeah, you saw the ones for 43 through 46.
Oh, find the exact value of the given expression. Well, now I'm in trouble. I'm at, I need the exact value of secant of the square root of 15 over 8. That's not the exact value. How do I find the exact value of that? I sure thought I was going about that right. What number is this? 4 what? 9? Cheat. I do just like you guys, right? Oh my goodness, they did it a different way than I did. Secant of the double angle, they put 1 over the cosine of that double angle. What the heck? I see what they did. Wow. Now I see why I didn't put this on test. Because I can't do it. How can I explain to you guys how to do that? I don't know what's wrong with what I did.
It's just like you don't know the secant double, formula for the double angle of secant.
Yeah, I see it. I see it. Okay. First of all, I messed up. I did it completely wrong. I got fired up and did the sine of the double angle, and that wasn't the double angle. It was 2 sine of the angle. Let's go back. Told you I was going to mess up somewhere. This is not a double angle. Fair? Where am I at? This is not a double angle. To get a double angle, I need sine of 2x. Fair enough? I didn't do that. That's different. That's different. So I didn't get anything right on this. So those of you that wrote down with me, I'm sorry, but you're going to turn that pencil upside down. Or you're going to have to keep it that way and just put a big old X there. Yeah, I hope y'all see that big mistake I just made right there. That's different than this. And I did this here. So what am I going to do? There. Turn the page. I'll admit when I'm wrong, and I'll leave it there for the whole world to see. Huh. Go back down here. Go back here. Don't know what that is. Take 2. Thank you.
Now we're on take 4, man. You hit it too many times.
Shut up. It might take that many. It might take that many. All right, let's go back to this. Well, it's a good thing I put the answers. I'd have been stuck with that one for a while. Mr. Willis isn't here today. I couldn't even phone a friend. Okay, so now let's look at it differently. Secant of a double angle. This is nothing more than an angle, fair? It's just an angle, so this is secant of a double angle, and I don't have a formula for the secant of the double angle, but I do have cosine of a double angle. And so to make that a cosine, I'll just make it 1 over about this? How about that? Sine of negative 1 to the 1 is 1/4 equals x. So now I just got an x. Now I don't have to write that down every single time. Y'all okay with that? And cosine of a double angle is 1 over, and cosine of a double angle is one of three things, right? We can do, is it cosine, sine squared minus cosine squared? Is that what it is?
Yeah,
Cosine squared minus sine squared is one of them.
or
1 minus 2 cosine squared,
Yeah,
or,
no,
no, 1 minus 2 sine squared,
yes.
or 2 cosine squared minus 1. I don't know. You got them right in front of you. There's three of them we can use. I don't know which one they want to use. I'll tell you which one I'm going to use. Because that told me sine, I'm going to just use the sine one. But if you use any one of the three, you'll get the same answer. Any one of the three, you'll get the same answer. But because I was told that the sine inverse is 1/4, I'm just going to use the sine. And the sine says it's, was it 2 sine squared x minus 1?
1 minus 2 sine squared.
1 minus 2 sine squared x. You okay with that? That's what cosine of the 2x is. Now I need to know what the sine of that angle is, which is nice. That's why you'll see why I did it. Now I don't have to draw a triangle. Because the sine of that angle is simply 1/4. So the sine of that angle is 1/4. 1 over 1 minus 2, 1/4, and it's squared because sine was squared. If you don't see that, then draw the triangle. Opposite over adjacent, and that was what, square root of 15?
Yeah.
Well, what's the sine of that angle? 1/4. And now hopefully you see why I just used the sine and not the cosine. But if you use the cosine, it's okay. You just have to draw a triangle. I didn't have to draw a triangle because I just used sine. And now we just got to simplify this. 1 over 1 minus 2 16ths. This is 1/8. 1 minus 1/8 is 7/8. Flip it and multiply it, and that's 8/7. And that's how they got it. Anybody okay with my math? Square that, it becomes 1/16. 1/16 times 2 is 2/16. 2/16 is 1/8. 1 minus 1/8 is 8/8 minus 1/8, which is 7/8. 7/8, flip it, multiply it, becomes 8/7. Woo! Yeah, I went about that the complete wrong way. If you did not use this one, you still would have got the same thing. You would have had cosine squared minus sine squared. Cosine squared was square root of 15 over 4, which may end up being 15/16 minus sine squared, and sine squared would have been 1/16, and 15/16 minus 1/16 is 14/16. 14/16 reduces to 7/8. Flip it, multiply, we had 8/7. So you would have got the same thing. Me writing this one down just saved me from having to write the triangle. All right. Better now? Woo! Hit the struggle bus on that one. Ran over it and backed up and hit me again. But we got it. Hopefully y'all saw where my mistake was. I didn't see it till I saw the answer, and then I came back and started to look where my mistake was, and now I see it. 2 sine of x is not sine of 2x. That's different. That's different. It's completely different. 2 times the angle is different than angle, sine of the double angle. It wasn't a double angle, it was 2 sine times the sine of that angle. Big difference. Big mistake. All right. What else, ladies and gentlemen? What else? Come on, it wasn't that easy. Nothing, nothing, nothing. Bree, nothing? Katrina, nothing? Man, you guys are so smart. This is tough stuff, I ain't gonna lie. It's stuff to remember. A lot of stuff to remember.
I looked at the answers after I was done. I got positive answers, but they had negative answers, and I'm still kind of confused.
For number 5?
Yeah, it's like the same one you did earlier.
Because truth be told, I think that's what us are going to miss on the test is the positive and negative things. So they tell me that cosine of x is 4/5. Okay, cosine of x is 4/5, but it tells me cosecant is less than 0. So cosine of 4/5 tells me, let me pencil. Tells me I'm in quadrant 1 or quadrant 4 because that's where cosine is positive. This tells me I'm in quadrant 1 or quadrant 4. I don't know. If it's cosine inverse, I'm in quadrant 1. There's no question. Because cosine of x equals 4/5. I'm either in quadrant 1 or quadrant 4. It tells me cosecant is less than 0. And cosecant is the same thing as sine. So if sine is negative, that tells me I have to be in quadrant 4. So x is in quadrant 4. And if I do cosine of x, cosine is adjacent over hypotenuse. But that puts that as a -3. Because of 3, 4, 5 triangle.
So I guess I'm just kind of confused. I kind of missed the part where you said 1 or 4. I get how you got there, I just don't know how you picked.
Because cosecant is less than 0. And for cosecant to be less than 0, cosecant has to be negative. And cosecant is the same thing as sine.
Okay.
And sine is negative in quadrants 3 and quadrants 4. And so the only one they have in common is quadrant 4. Okay, you're good now?
Yes. Thank you.
Everybody else okay on that? That's going to be, I mean, that's I think one of the harder things is trying to decide where x is and then what makes that positive and what makes it negative. And it's that cosine is still positive because cosine is 4/5. But it changes your sign because sine will be -3/5. So the negative, and the hypotenuse is always positive. Hypotenuse is always positive because you always want to do x squared plus y squared. So that's going to make them positive. Hypotenuse will always be positive. So even if they tell you that cosine of x is -4/5, the 4 is negative, the 5 is positive. Okay with that? That's a good question. That's a good question. I probably should have done a better job of covering the other day. Simplify using the double angle and half angle. I think there's a question like that on the test. So we'll give it to you as the double angle or the half angle. We want you to convert it back into the original. That kind of makes sense. I'm not sure what we ended up deciding on this, but there were some, find the exact values. There's definitely some questions like that. Find the exact values. Again, I'll go over all this on Friday on my video. So I'll do it live during class. Like I'll talk to you and you guys can talk back to me. I'll just do a Google Meet. That way you guys can actually chit chat with me and all that. But I'll record it and then I'll post it. So those of you that don't get on there can do it later. It's your choice. All right. You think we're okay? The next two sections are solving, and you have to know how to do everything else in order to solve. So the majority of the test is going to come from the actual solving part of it. Does that make sense? Because you have to know how to do it to solve. So why not just throw it all kind of into one question? So here we go. 7-point quadrilateral, which I need to go here. And I need to open it up, file. Now surely it's a recent, but I just made it this morning. It's not showing up as a recent. And I just made, no, I didn't, I made it last night, didn't I? 7-4, driver's license, it's not there. All right, we'll do it this way. File,
Why do you have your driver's license in a PDF?
I take it when I got my shot.
You just have your driver's license on it?
I had a copy of it.
What?
I have a copy of it. And so I keep a copy on my phone. And when I mailed it to me, it came up as a PDF. But it came up as a whole freaking page. So I had to shrink it down anyway. You don't care. 7.4 book. Here we go.
I guess it makes sense if you forget your wallet and you're driving, get your driver's license on.
Told you I wasn't born this last night. We know this one, sine squared plus cosine squared equals 1. We know that 2 sine theta minus 1 equals 0. We know sine of 2 theta minus 1 equals 0. All equations is called trigonometric equations, yada, 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 yada. This is vanity, basic trigonometry, solving. Here we go. Jump right into it. What?
You never get tired of it, don't you?
I never do. I never do.
How long have you been teaching?
A long time now.
I bet you make that joke every.
No, once I started though, I haven't stopped.
That's good on you. Good on you.
Thank you.
Consistency.
Well, that's what I try to do. Now, the one where you ask, can you work? I got that from my college calculus 2 teacher. Can you work number 16? He goes, yep. Just sit there. I can work them all. Smart aleck. It's all right. He's part of the reason why I do what I do too. He's good.
So we have him to blame.
Yes. Mr. Mullen.
Mhm.
Wasn't even a doctor. I had Dr. Watson for Cal 3, and I dropped that class quicker than I could do anything. When we got our first test back, I got a 16 on it
Ooh, out of 100?
out of 100.
Oh,
And it was the second highest grade in the class. Yeah.
yeah, drop that.
Yeah. I'm thinking, okay. A 16, how am I getting an A off of
An issue with her teaching or,
him? But yeah.
or him?
Oh, yeah.
That
He was a
curve,
fruit.
that's one heck of a belt.
Yeah, he was a fruit. I'm done. He was blue.
Wait, because it was the second, what was the first highest?
17.
Oh, wow.
Yeah.
So wait, does that mean that that's 17?
So I had an A, but I still dropped it because I said, I'd like to learn something.
That's brutal.
Anyway. Okay. Solve this equation. It doesn't get any easier than this right here, guys. It does not get any easier than this one.
Can this one be on the test?
Oh, get really close.
Oh,
Fair enough? Solve the equation. So here we go. We got sine of theta, and use x, whatever you want to, right? I don't care. Equals 1/2. When, and I don't know, they don't tell me if they want it in radians or degrees. So I don't even know. When is sine 1/2? 30 degrees?
Yeah.
Or pi over 6? And I don't know if I want it in radians or degrees. They're doing radians. So let's do radians.
Oh, yeah. Do they want both answers?
Oh, so that's the trick. As one of my students used to say, what's the catch? What's the catch? So,
there's always a catch.
We all know, or at least I hope we know, after doing the unit circle for about a month and a half, that sine is 1/2 right there, which is 30 degrees, or let's use radians, and so it's pi over 6. So pi over 6 is definitely an answer. But you guys, being really, really intelligent people and gotten a great lesson over the unit circle, also know that it's 1/2 over there. And that happens to be 1/6, 2/6, 3/6, 4/6, 5/6. So theta can be two things. Wait.
Back to this. Oh, no.
Can be
Oh, no.
It can be
Stop it.
infinite number of solutions. But it can't be it's not all solutions, right? It's only a certain thing. So here's how we're going to do this. First, we're going to find the first time it happens. We're going to find the second time it happens. Sometimes there may be more times that can happen besides just one or two. Who knows? Depends on if it's a half angle or double angle. And this particular one is just sine of theta. So it only happens here in 1, and it happens in quadrant 2. When it gets to 3 and 4, it's negative. So I know that theta can be pi over 6. I also know that theta can be 5 pi over 6. Then it can also be so that ends up being 13 pi over 6, but we don't want to list this because we didn't list 13, plus then we list 25. And then, no. Has everybody freaking math tested? What's my say? Okay, I'll send it to you. Oh, bye. You know, there is several things in life electronically that will help you do. And one of them is if you get a fancy watch and you turn it on, it works a lot better. Hold on, sorry. All right. So instead of writing the 11 or pi over 6 plus the next one, plus the next one, plus the next one, we're going to cheat, kind of, and just write plus 2 pi k, where k is the number of times we're going around. Because not only can we go this way, right? We could go negative. So k can be a -1, it could be a -2, it could be a -3, it could be a -4, it could be a +5, it could be a +6. If it's +6, that just means we went around 6 times. And so that's why we look at this answer, but then we just add 2 pi to it. How many times do you add 2 pi to it until we want to know? So it's infinite. We can just keep going infinite number of times. And so what do we need to do this bottom one? We'll do the same thing. Plus 2 pi k. Y'all okay with that? Now, if they limit what x is, like sometimes they put a restriction on the domain. Fair enough? So if they limit it, we can't do this. We have to just find the ones that will work inside the one that's limited. So that will happen a couple more questions throughout this examples. Everybody kind of okay with that? So it's a pretty simple little question, but it comes up to be a little bit harder than just saying x is 4, like we used to. So it's 1/2 here, it's 1/2 here, but it's also here, 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 or here, here. So if there's infinite number of solutions,
I hate circles.
but it's not infinite. But there's an infinite number, but it just happens at pi over 6 and every 2 pi after that because it's just a circle. If we were doing degrees, we would say 30 plus 360k. Okay with that? Same thing down here, 5 pi over 6. And technically, you could say minus 2 pi k, because there's nothing saying k can be negative. So this is kind of an arbitrary type answer that we just pretty much have to add to all these, as long as it's sine or cosine. Y'all okay with that? Let's go on to the next example. All right, so solving any trig equation always reduces the solving basic trigonometric equation to form number 2. Find the solutions in one period, and then find all solutions. So one period just gives me the pi over 6 and the 5 pi over 6. One period, one cycle. But the infinite, we do the 2 pi k. They do 2k pi. Oh, whatever. I do 2 pi k. Here's the solutions for one, but then there's the infinite solutions. I'll kind of just see that as a graphic representation. Here's the next example. Let's take a picture of it. All right, come on. Solving basic trigonometric equation, example number 2. Solve the equation cosine theta. Again, guys, if you don't like writing theta, write x. And list 8 specific functions. So that's a little bit different. I'm not going to worry about that until the end of it, though. So cosine theta equals negative square root over 2. Well, where's cosine? Quadrants 2 and quadrants 3. And I want negative square root of 2 over 2. You may need your unit circle again. I don't know. Hopefully you have that somewhat memorized. 1/4, 2/4, 3/4. One fourths, 2/4, 3/4, 4/4, 5/4. It's just kind of really blowing up now. Sorry. Y'all okay with that? How many did I find? 2. So we just, and again, it comes out to plus 2 pi k plus 2 pi k. So now it's Burger King your way, right? You can let k be 1, actually you can let k be 0. If k is 0, it gives me that one. That's one solution. K is 1, that gives me 2, 3, 4. You can just keep going with this one if you want. It doesn't say which 8. It just says 8 specific. So they don't put any restrictions on it. You just need 8. Ask you to give 4 from this one and 4 from this one. But I don't know if you need to go positive or negative. Y'all okay with all that kind of stuff? They could be negatives too. So you can say k is negative 1. Whatever you got to do. Whatever you got to do. If it's 2 pi, it's the same thing as 8 pi over 4. So add 8 to this, add 8 to that, add 8 to that, and just keep adding 8, and you just got them all.
Where did you get the 3 pi over 4, 5 pi over 4?
Because that's where cosine is negative square root of 2 over 2. Because that's that distance there. Fair enough for that from the unit circle. So that's actually part of the hardest part. Once we know that, it's always going to be 2 pi k for sine and cosine.
So then how do you get all 8 of them?
So we'll just plug in some number for k.
Like 1.
Fair enough. And then again, guys, just kind of make sure that it's not that difficult. Don't make it too, I mean, it may sound worse than it is. Turn the page. 3 pi over 4. So let's go, I will go ahead and do that. 3 pi over 4. And then 2 pi equals 8 pi over 4. 8, 9, 10, 11. 11. Plus 8 more. Or we can go this way. I can subtract 8 pi over 4. Fair enough. They didn't tell me which ones I can do. So that's 4 of them I listed. I just need 4 more. And I probably would use, what was the other one? 7? 5.
5.
And I'd probably just add 8 to this one. 8, 9, 10, 11, 12, 13. Add 8 more. 8, 21. And then you can subtract 8 or add another 8. Doesn't matter. This is where it becomes, there's 16 of you guys. It can have 16 different, there's no way. That's why I put limits on it. That's why I put limits on it. You okay with that, Em, now?
Yeah.
I need to thank you guys. I'm glad you asked that because I assume that stuff's easy, but I don't want you to miss something that's easy. Talk to me, my dear.
Are we supposed to put the best two high thing after every?
No, so that's because this one wanted specific answers.
Okay.
Okay? If you want to, if they want all the answers, that's what we'll do 2 pi k. Fair enough? That's a good question too. So because they only wanted 8, specific solutions? Is that what actually it said? 8 specific solutions, then I don't have to put plus 2 pi k. If they wanted all solutions, I'd have to put plus 2 pi k. Okay? Everybody okay with those 2? Now, they're going to get a little bit harder than that. So let's go up here to example number. They're showing you the circle of all that stuff there. If we find all the solutions, there's a 2 pi k, okay?
So it's like there's 2 solutions and number at those 2 locations.
Right, so there's 2, I guess, unique angles, I guess. 2 between 0 and 360 or 0 and 2 pi. There's always going to be 2 of those. And then it's every 360 after that, or every 2 pi after that. And so here's where they said k is -1, k is 0, k is 1, and k is 2. A lot of times we'll put restrictions on it, so that way I can't have 18,000 different answers and it takes forever to grade. Everybody okay with using a calculator on that one? I have to use a calculator on that one. Because I don't know where cosine is 0.65. So do cosine inverse. And then just add 2 pi to it, 2 pi to it, 2 pi to it.
Did you say we would have calculators or we would
You wouldn't, so that's why I'm not gonna give you that one. Fair? That's a calculator one too. I don't know when tangent is 2. Tangent is 1. I don't know when tangent is 2. All right. A little bit of work before we just solve it. So here we go with this one. I'm just going to do the there. 2 sine theta minus 1 equals 0. Anybody got a wild guess at what we need to do first? Add 1 and then divide 2. And now we have sine theta equals 1/2. Kind of see how it works. So this became example number 1. This became example number 1. Yeah, sine is 1/2. Find all the solutions. So when is sine 1/2? Pi over 6. 5 pi over 6. And if we want to find all the solutions, hate that they gave me one exactly like the other one, but it really wouldn't have mattered. I found that part. They could have used cosine on that one, and I've done the same thing, except it wouldn't have been power of 6, it'd been power of 3. Yes, ma'am.
So for 7.4, is that basically all we're doing? Just like-
Solving for x or solving for theta.
Okay.
Fair enough?
Mhm.
Now, they're not quite this easy always. Sometimes it takes a little bit more. And then we'll get into 7.5, which takes it even a little bit further.
How does it do that? Like,
We'll have to start using some of the double angles.
oh,
We'll have to start factoring some things. We'll get some, what do you call those things? Extraneous answers or extraneous angles.
they just always find a way to
Yeah,
make it more
I mean, they-
confused.
What's the catch? Alyssa Schultz. Alyssa Schultz, bless her heart, her pre-algebra, algebra 1, algebra 2, pre-calculus, statistics. 5 years I had that little girl, bless her heart. But in algebra 2, when I was in the other building, because this building wasn't built, right in front row. Alyssa, Bonnie Mertz. I her name was, but she was always dressed to the nines. Boy, she was just elite every day. One day she came into class and her feet hurt. She goes, my feet hurt. I said, well, wear tennis shoes. She goes, I'm sorry. Anyway, we go over the lesson every time. She'd get halfway through. She goes, all right. There's not one.
That's a lie.
Anyway, I was kind of impressed. I can't remember her name. I can look at Megan O'Brien. Just hit me. Megan O'Brien.
Pretty good memory.
That's not bad, is it? See, some students leave an impression, but you teach them for 5 years. You don't have a choice but to try to remember that one. Some of you, bless your hearts, I've had you all for 2, maybe 3. Bless your hearts. But kind of neat that way too. I get to see y'all grow up, and I'm the one responsible for you. So if you don't know crap, it's my fault. All right. Let's do the second one. Let's do tangent. I think I can I do tangent 3? Yeah, I thought so. Oh, it's tangent squared 3. Oh, that makes sense. Okay. Tangent's a little bit different than sine and cosine. Tangent's a little bit different than sine and cosine. Let's kind of lead into it already. Right? Tangent is positive there. Where else is it positive? Quadrant 3. Right? Because it's negative, negative. It's negative here and here. And if it's that angle, then it's that angle here. So tangent happens twice, but it doesn't happen twice. Sine, it happens here and here. Cosine, it happens here and here. Tangent, it happens here and here. Or here and here. Or here and here. So tangent really only has one answer, and then instead of adding 2 pi k, we'll just add pi k.
Why does it only
So it does happen twice. It just doesn't happen in 2 unique places.
So that means we'd only
So
have
you
to
just
put the
have
one.
one.
So you really only have
Pi k.
yeah. So instead of like this one, where's my previous page, right? This one we kind of set up as 2 different ones, right? We set up this one and this one. Tangent will only have like one of these. Instead of adding 2 pi k, we'll just add pi k to it. And that will take care of this one and this one.
Get them out of here.
And then it take care of all of them. So tangent's a little bit different than the other 2. Sine and cosine, secant, cosecant, are 2 pi k.
So you just have to,
But tangent and cotangent is pi k. So it actually ends up being a little bit easier because you really, once you find the one of them, you don't have to find the other one because it's just pi k after that. Talk to me.
Is it kind of like when we graphed it?
Yep, that's exactly right. It's the period. That's exactly right. That's a great tie into it. Right? Tangent's period was only pi k. because it happens twice often. Cycle.
Are they just the same?
Yep. Okay with that kind of? All right, so let's go back to this page here. And let's get this thing here. Uh-oh, I didn't want that. I don't know why I just did that. That's what I wanted. Tangent squared theta minus 3 equals 0. Hopefully we can start solving this for theta pretty easily by just adding 3 to both sides. And after we add 3 to both sides, we'll have to take the square root of both sides. And so tangent theta equals square root of 3. Uh-oh, careful. Plus or minus. Plus or minus. So this one is going to end up happening a lot of times. Because tangent can be positive square root of 3 in quadrant 1 in quadrant 3, but it can be negative square root of 3 in quadrant 2 and quadrant 4. Well, this is going to happen a lot of times. That's what happens. But now I got to figure out when the heck tangent is the square root of 3. And that's when it's the square root of 3 over 1. It's either 30 or 60. Is it 60? So sometimes you have to kind of really think back to your unit circle about tangent. Tangents always take me a little bit to try to figure those out too. So 60 degrees, or that'd be what, pi over 3? Okay. So theta, pi over 3. Here, let's I might need a circle here. So that's where it's positive square root of 3. It's negative square root of 3 there. 1, 6, 2, 6, 3, 6. That's 4, 6. Which is 2 pi over 3. And then it's here, which that one is the 180 from it. And then it's here, which is the 180 from that one. So we have it. We'll just have to add the pi k here and add the pi k here. And that's going to take care of the first time, the second time, the third time, the fourth time. 5th, 6th, 7th, 8th, this is going to take care of all of it. Everybody okay with all that? So I know when we were talking about tangent, we really only have one of those, but the reason why we have 2 this time is because we had to do the plus or minus. And that allowed me to have 2 of those. Okay, in sine and cosine, we could have had 4 of those if we had to do the plus or minus. Notice what they did. They did pi over 3 and negative pi over 3. So they gave me quadrant 1 and quadrant 4's answer plus 2 pi k. It doesn't matter. That's why there's infinite number of solutions on this. So we did quadrants 1 and quadrants 2 and 2 pi k, or sorry, pi k, which takes care of quadrant 4. Or if we go k is negative, it's going to take care of that negative pi over 3. So when you look at your answer, if you don't have the same thing they do, it's okay sometimes. You just have to think about what k might be. Okay with all that? Let's see if we can amp this up a little bit more. Uh-oh, what happened?
You hit the wrong one, I think.
I want that. All right. 2 cosine squared minus 7 cosine plus 3. Happy, happy, joy, joy, happy, happy, joy. This is when the nerd math comes out of me, boy. Woo! 2 cosine squared theta minus 7 cosine theta plus 3 equals 0. You didn't sign up for this when you came to Arkansas, did you? First time to Arkansas, were you scared about coming to Arkansas? Or did you?
Yeah, it's my first time.
Yeah? Is it what you perceived it to be?
Not really.
Not really, huh?
Bentonville's a bit different.
It's a
The
bit
rest
different.
of Arkansas.
This is not Arkansas. Just so you know.
Stay in
It's a
Bentonville.
very small area of it, and it's not the majority. Trust me, I've lived several places in this state, and people when you go, like I go to coaches class, and they say, "You're from Arkansas," I said, "Don't you?" I said, "Think of a suburb of Chicago." I said, "Yeah, that's where I live." Really? I said, "Yeah, pretty close." I don't know what you think Arkansas is. We don't have outhouses. I gotta factor this.
Most people have all their teeth.
I mean, it's a little different. This is not Arkansas, just so you know.
It's nice here.
Yeah, it's not bad, is it?
Don't go south.
Easy. I like it down there too.
It's nice. It's
2. So if you have a tough time factoring this, just go over here to the side and say it's 2x squared minus 7x plus 3. Fair enough? You have a tough time factoring that, which you do at first because it's just tough to see. Change cosine theta to x. And then factor it. And then factor it. Okay? This will go to 2 cosine theta, cosine theta, and I got to get 7 out of this somehow. -7, -1, and -3. And again, if you have a tough time with that, go over here and do it. And then how you do it with a leading coefficient, I don't have any clue. You guys do the AC method or whatever you got to do. Factoring's important. Now, each factor we can set to 0. So we'll have 2 cosine theta minus 1 equals 0, or cosine theta minus 3 equals 0. So now we've set this up in a big time question, right? On the left hand, we've got cosine theta equals 1/2. Cosine theta equals 1/2. Over here, we have cosine theta equals 3. That can't ever happen. Remember, cosine has a domain or a restriction for the range values. It only goes from -1 to 1. So there's no way for cosine to ever be 3. However, cosine can be 1/2. Cosine is 1/2 at 60 degrees or pi over 3. And it also happens at cosine's positive, quadrant 4. It's easier to just go negative pi over 3. But if you want to continue to go around, we can go around. It doesn't matter. Right? I just got to get to this angle. And it's a whole lot easier to just do negative pi over 3. It doesn't matter if you do negative pi over 3 or you do what? Let's see, 1/3, 2/3, 3/3, 4/3, it'd be 5 pi. So if you want to do 5 pi over 3, do 5 pi over 3. If you want to do negative pi over 3, do negative pi over 3. It's easier to do negative pi over 3. You don't have to think about how it is go all around, just go down. And then we got to do plus 2 pi k. because I think it asks for all the solutions. Still okay with that? Again, this does not have to be negative pi over 3. It could be the 5 pi over 3. This does not have to be pi over 3. It could be negative 5 pi over 3. Yes, no, maybe? Starting to get a little harder. We're getting closer to being done.
Coach Mayor,
Yes, ma'am.
so whenever we're factoring one of them,
Yep.
will it always have an answer that you eventually throw out because?
No. No, it's possible that you could have a 1.
Okay.
And so you'd have to solve for this one, solve for this one. So you'd have 2 possibilities here, 2 possibilities here, and yeah, it's nasty. Okay? A lot of times it will, and a lot of times it won't. Let me make sure I got that right.
Yeah.
Are you good? Thank you. All right. Woo, now we're gonna get here a little hard. This is number 7. It just says solve. I'm assuming again, when we solve, we just find all of them. I'm not, to me, if you can find the first one and the second one, you're golden. Solve the equation. 5 sine theta. 5 sine theta cosine theta plus 4 cosine theta. If you have a tough time seeing things, let x equal sine theta and let y equal cosine theta. I don't know. It's not quadratic. Can I take something out of both of those? Cosine theta. Oh, that's not hard. Hopefully everybody here saw it and y'all were thinking like, what the heck are you slowing down for? Take out a cosine theta. If I take out a cosine theta, here I have a 5 sine theta. And here I just have a 4. And so now we'll set each one of those equal to 0. It's real important to put that or in there. Me and Mr. Willis were talking about that yesterday. A lot of times you guys haven't, I don't think you guys have been taught the and or the or a whole lot. There's no way to be an and on this. There's no way for X to be 1 and 2 at the same time. It can't happen. It's 1 or 2. Anyway, I don't ding you on that stuff, but it just starts to sound like you don't know what you're talking about when you start putting wrong. What is that?
Notation.
Wrong vocabulary. We'll just leave it like that. Thank you. When you start putting the wrong vocabulary, I don't know what that is. 5. Whoops. Sine theta plus 4 equals 0. Over here, this is easy. When is cosine 0? That's when my dog doesn't have to go anywhere. Straight up in the air. Oh, this is a little bit different, right? So it happens straight up here or straight down here, which now I don't have to list both of them. I just need to list one of them and then add, not 2 pi, just pi k. Now, is it wrong if I list this one and add 2 pi? No. But you're just saving yourself some work. If I list this one and just add a pi k, I'm hitting all of them. But if you want to list this one and add a 2 pi k, and then list this one and add a 2 pi k, you're not wrong. You just won't see it that way. So don't think there, oh my gosh, how do I know which one? You're not wrong. You can list all of them if you want to. Just you're wasting lead. So theta pi over 2 plus pi over k. Cosine and sine are special when it's 0 or 1. When it's zero, actually one, it's not, because one is only one or negative one. So one is still be two pi k. But there'd only be one answer as opposed to two answers. This one is sine theta negative 4/5. And I don't have a clue when that happens. We gotta use calculator. Fair? I don't have a clue when that happens. So we just have to do sine inverse of 4/5 and then add two pi k to it. And actually figure out where the other one is too, because they're only going to give you one of them. Hopefully we didn't get any of those in the homework, because they're not gonna have you on the test. Yes, ma'am.
Why would you not draw a triangle with the negative 4/5?
I guess I could. No, because I want to know what the angle is. I
Okay,
could draw the triangle, but I still have to figure out where the angle is.
okay.
That's the difference in what we were doing previously. I want to know what the value of sine was at that. So whatever this angle is, the value of sine is 4/5. That kind of makes sense. I'm trying to solve for the angle. I actually need the angle this time. All the previous stuff, I didn't really need the angle. I needed the value of the trigonomic function at that angle, which was the value of the triangle.
Okay.
It made me think for a second, though. That's a good job.
So when you're plugging into the calculator, you just put sine inverse.
Yep, negative 4/5. So let's do it just to make sure, okay? In case we have to do that. I don't want you to have to miss that because of that. On the test, like I said, all of them you'll know. Okay, all of them you'll know. So you'll do sine inverse. Oh, make sure I'm in radians. I'm in radians. Sine inverse of 4/5. And there's that value, right? And then we'll just add two pi k to that one. But then you also have to figure out the other time it happens.
Would it matter if?
Was it negative?
Yep.
I'm sure it will. Negative. And then we also need to get it in quadrant 3. So that becomes it's harder to do this with a calculator than it is not, right? Sorry about my marker. But it happens here, and then it also happens over here. You got to figure out where that is. So you got to figure out that this is the distance here. That's 0.92. You got to figure out the distance from here to here, which is 2 pi minus that. But then that's 1 pi minus that. Y'all okay with what I'm talking about there? I'm assuming I'm not too worried about it because it's not on the test, but I do think it's something you kind of need to know. But to get that second angle it's harder to do than just know the unit circle.
So why didn't you use two pi k on that last one?
Here?
Yes.
Why did I not?
Yeah.
Because cosine is 0. Let's put it up here. Cosine is 0 right here. And so I could do pi over 2 plus 2 pi k. I could. But it's also 0 down here.
Oh, okay.
And that's just pi.
So you could write that two equation if you wanted to. But
Two
that's-
equations if I wanted to and put 2 pi k. We're just wasting lead.
Yeah.
Fair enough? Everybody else okay on that? And like I said, this side over here, I'm not too concerned with. I hope there's not a whole lot of that in their homework. They should have easily made that 1/2. I could have easily made that 1/2. Square root of 3 over 4 or whatever. Not square root of 2 over 3 or. Let's see if we got another one. Oops. Is it start exercises?
Yeah.
It's kind of nice when y'all are with me on that. Okay, what are y'all supposed to do? 3 through 51, every other odd?
5 through 53.
5 through 53, every other odd. 5, it sounds like a lot, but when you do every other odds, it goes pretty quick. 5 through 53, every other odd. If you can do this stuff, you can do a lot of other stuff. On Thursday, it's going to be more solving. 7 points. for the more solving. But you have to use some identities to solve them. You have to use some identities to solve them. I need to go here. I had one person. Ooh, that's not bad. Oh, it was? Or is it just, huh?
It's Drew.
Oh, yeah. Drew, he said that.
In stats, you had 7.
Yeah.
Huh?
Very popular.
Yeah, we had stats had 7 live.
That's not-
It wasn't 7:15 in the morning though either. So as soon as